Okay. So just hang on a sec. Just need to test one more thing. Hi everyone. I'm hoping that you can hear me here. This is the first time I've done a remote presentation, so really I am testing the demo gods tonight. So I just thought I wanted to tell you guys about FSQ, which everyone, well, not everyone down here, but a small group of us down here in Hobart and up in Launceston have been playing around with. Yeah, it's a relatively new digital amateur mode, but and I've been doing a few different things with it just to sort of spice things up. But basically, what we do here is on Friday evenings at 8 o'clock, we have this thing called FSQ Fridays, and it's just a 1 hour net where we get on FSQ and see if we can make contact with each other and try out the different features of FSQ. So, what I thought would be interesting is that although it's not exactly SDR stuff, it is a digital mode, and what I've done with it is actually combine it with an Arduino to sort of make a software-defined beacon, so to speak. So if you're familiar with PSK31, I think a few of you might be if you've been to a tutorial at RuxCon about that. So it's similar to that, but it's created by someone in New Zealand called Murray. Can't remember his last name. And the letters and numbers and some additional characters use 1 to 2 tones each. And uppercase requires 2 tones. So when we use FSQ, we put our call signs in lowercase because otherwise it takes twice as long to transmit them. It's not a high-speed digital mode. PSK31, as you could remember, is about 3 baud or 3 characters per second. FSQ actually has different rates and which you can change depending on your signal quality. So it can go from 2 baud up to 6 baud or 6 characters per second. So yeah, what we try and do with FSQ on the FSQ nets on Friday is we get together on 2 meters or 144 megahertz, and that's more of a local conversation and sort of point-to-point line of sight. Then we'll switch down to 7 megahertz, so that's 40 meter band, and that can go a lot further. We've actually gotten some contacts with Launceston and some even with New Zealand, and part of the reason why I thought I'd tell you guys about it tonight is because you guys are just over in Melbourne, and if you've got an amateur license or you're looking to get it, you should try out FSQ and see if you can hear us down in down further south. So what else can do? Let me just actually give you a quick demo. Hang on a sec. Am I back on the? Hopefully, I'm back on the camera. So normally, what I do with digital modes is I've got an ICOM radio, and I use this Signal Link, which is basically a USB sound card on the back here. That goes into the radio. That goes to the computer, obviously. And then I can basically use this, and it uses a Vox to do push to talk. What I've found recently, though, is I've been able to do similar things, receiving at least the digital modes with my RTLSDR, which I'll show you a bit later on. So let me go back to the screen sharing and share a different application which has crashed. Hang on. All right, let's try this again. And here we are. Here's FLDigi, which is what I use for all of my digital modes. And if you go up to the op mode, I'm not sure which version FSQ started appearing in this, but version 4, which you can download the source for, is definitely got it. So you can actually choose FSQ mode here, and it changes a little bit the screen. It actually gets you this left panel here, which is the list of call signs that you've heard from. And so down the bottom of the screen, you've got the waterfall, and down the bottom left, you can actually select, and it's not appearing on the screen, but you can press that FSQ 6 button and actually choose the speed that you want to do. What I'm going to try and do now is, so it's basically instant messaging for radio, and it should sound like this. And well, there you go. That's 6 baud. Whereas if PSK 31, not as musical. Sorry about the noise if that was annoying. So the other thing I was going to show you with the demo is with the program is with FSQ. Got to open it again. And press this button. There's a monitor window where you press the Mon button and you get this monitor window. And it basically, what it tries to do is it tries to decode the packets, but sometimes some characters get lost along the way. And don't get decoded properly in the main window, but you can actually kind of see the mistakes, all the mistakes in the monitor window, which is very good for testing anyway. So let me go back to the slides. All right. So why would I want to use FSQ when there's already all of these other digital modes, as you saw in that menu? And well, it's new, but it's got some really sort of nifty features. It can do things which are called automatic triggers. And this is essentially the bots of the of this instant messaging platform. So I've got a friend of mine, VK7NTK, his name's Tom. He might be away from the keyboard, but I want to see if he can receive me and how well he can receive me. So I can just type in VK7NTK ? And his computer will automatically transmit back a signal report, which is incredibly useful. I can leave my computer on all day and people can sort of listen out for me and then try and see if they can be heard without me even being there. Me being outside of Hobart, about 50 kilometres outside of Hobart, I can't hear everyone, but it'd be interesting to see how much that Tom can hear in Hobart. And so I can actually go VK7NTK @ and his computer will respond with the list of call signs that he has heard recently and what their signal strength is. So there's a whole bunch of these automatic triggers that you can try, but those are the more ones which we try every Friday. But this is the sort of killer feature of FSQ, and that's relaying. So I've got another friend of mine, Ian, who is on the other side of Hobart, And I can't hear him at all because he's down the valley, but Tom can hear him. So I can actually just go VK7NTK, semicolon VK7IS. And what that will do is Tom's computer will automatically retransmit my message. And then Ian, or VK7IS, down the other side of the state can actually respond. And yeah, so the transmit from Tom actually looks a little bit different. So that's it tells you that the message is for VK7IS, and it's from originally from me, VK7LXX, and then he can respond to that later on. And also an automatic upload and download service. You can basically, so if I've got what I've done is I've got another radio, and perhaps one of these beacons, which I'm going to show you about shortly, and that has got a temperature sensor on it, or a weather or barometer or whatnot. Then I can have that beacon transmit like once a minute or once every 5 minutes or something like that. Special string VK7LXX hash, name of a file, and then the text that I want appended to that file. And then my computer, which is running FLDigi, responds back with a transmit ACK afterwards. So yeah, so I've put a little weather station outside. It transmits data with this beacon. And I don't need the beacon to actually receive in this case. It can just transmit blind once every 5 minutes or so. If I'm, say, at work in Hobart and I want to see what the weather is at home, but I've got a radio, I can actually go, or Tom wants to see what the weather is at my place, he can actually get sent the entire weather.txt file by typing in VK7LXX plus and putting the name of the file that he wants to receive. So yeah, that's sort of the best features of FSQ, which I wanted to use it for. And as you can see, these automatic triggers are kind of useful, and that's why I wanted to actually see if I can automate it. And also, the reason why I did it is it's simple, as you'll see shortly. I wanted to turn it into an SDR application. That's still a bit of a work in progress, but I was able to complete the hardware part in about a couple of hours on the weekend. Everyone loves to build a kit. You know, Hardware Hacking Village at all these cons is, you know, heaps of fun. And you can never have too many side projects. So I was able to knock this one off pretty quickly. What am I using? So before I get to let me show you what it looks like. Application window. Wrong window, sorry. There's the beacon right there. This on the left side is an Arduino Nano, which I had lying in the shed, costs about $5. And the main component here is the Adafruit SI5351 clock generator. Now, it's an I2C device, so you're basically just changing the clock signal when you want to transmit. So it's basically making a square wave, pumping out a square wave signal of about what you want to receive. However, as you know, square waves and transmitting square waves is not very good. And so what I wanted to do is add a filter to it, and that's on the right-hand side of the PCB that's on the right. I went looking for a filter, and I could get a filter for $20 at this place called Mini Kits. But for $50, I could get a 8-watt amplifier with the filter. So I thought, oh, I'll just get that. That way I can transmit this beacon at 8 watts. Everyone will hear it. It'll be great. It's pretty good. However, I found that there is still, I'm not exactly happy with the filter. So I'm going to get another filter for mini kits and put it before the amplifier, so it'll filter it before and after the amplifier. So yeah, so that's pretty simple to build. And as you can see, it's two main components there. But the 5351 is the clock generator. This little Adafruit board, breakout board, can give you 3 independent clocks. So the chip itself can do 8. It can go 8 kilohertz up to 160 megahertz, and it's controlled with I2C. So it's trivial to make an Arduino sketch. But the best thing about it, it's $15. So this whole kit has cost me, $50 for the amplifier, but it's cost me essentially $20 for the clock generator and the Nano. So yeah. I found out that someone else had already written a way to encode FSQ, because they'd encoded JT65 and all of that using the same SI5351 library. And if you go to the Manage Libraries thing in your Arduino and look for JT encode and SI5351, you'll actually find those in the downloadable libraries. Yeah, so not only can it do FSQ, it can do JT9, JT65, and Whisper, which are very, very weak signal methods of modes, which seem to be all the rage now, especially if you're putting things on a balloon or bouncing stuff off the moon. And the amplifier is the mini kit's 8-watt amplifier. It's around 25% efficient, so it gets quite warm. Now, here is a little bit of hardware problem I had, is that the clock generator, the minimum output is 2 milliamps, so that would be 15 milliwatts. The amplifier requires maximum of 5 milliwatts, so I could either operate it without the amplifier, which should actually be kind of a useful thing for testing, or if you perhaps wanted to set the beacon up as a fox hunt target. But what I did, so what I had to do, and I'll just skip a slide here, is actually put an attenuator between the clock generator and the amplifier, and that's 3 resistors, and I could actually just put those directly on the amplifier board using surface mount resistors. So that reduced the signal from 15 milliwatts down to 5 milliwatts, which is exactly what we need here. So what's the code look like, you say? As I said, the library can do other modes as well. But what it does is it grabs your message and converts it to a series of symbols, and then when it transmits, it basically just goes through each symbol. So each character is 2 symbols, and it will basically set the frequency and for each symbol, and then delay for a tone, and then change, and then move on to the next symbol. So that, really page and a half of code, when you start it up, you can actually set how, if you want it 2 milliamps or 8 milliamps, depending on the output rate that you want. So yeah, that was, as I said, trivial. So I've got a beacon now. So what does it sound like? Now, here is where I really tempt the demo gods here. So one of the things I wanted to do was actually put this, have this connected to a Raspberry Pi via serial, and then have that Raspberry Pi listen using FLDigi to, let me have a look, sorry. It's what it's trying to do, and then it's listening with FLDigi with an RTLSDR and actually transmitting using the Arduino. I haven't gotten quite that far yet, but I'll show you sort of a work in progress. I left my RTLSDR at home today, so you'll have to, hopefully the Lime is going to work. Yes, it is. Application window, share. Open on USB. All right, let's plug it in and see what happens. That clicking sound has actually only just started happening this evening. It's usually quite, usually doesn't have that clicking sound on it, but it doesn't matter. If I stop that and change, one thing I found you can do with Linux is if you go modprobe snd-a loop, you can create a ALSA loopback device, and I can go FLDigi, GQRX here, and that is now going via the loopback device. And so this is transmitting. Here we go. Oh, there we are. It's going to transmit, and as you can see, it actually didn't decode one of the characters properly there for some reason. I think my clock is slightly off. Yeah, and if I just show you the FLDigi window, especially the waterfall down the bottom there, you'll see that there's the tones. With FLDigi, with FSQ, the tones need to be really at 1500, so they've shifted up as well. So I think that's just because I've set the wrong frequency in GQRX. So yeah, so there's my beacon. It's transmitting that at the moment, and there's a big nasty square wave, and I'll turn it off now. Fortunately, there's no antenna on it. But yeah, nice simple weekend project. Now, what was I going to do last? Last bit of it was FLDigi actually has an API, which is not in this window. Yes, it is. Application window. Yeah, so I'm using a Jupyter notebook here, and I use PyFLDigi, and then you can just query it. You can actually set the mode that you want to use, and of course, then it breaks, probably because I've closed FLDigi right now. But yeah, so my next bit was actually to basically call the API to look in the receive window and keep listening in the receive window for anything that's changed. Yeah, and yeah, that's about it really. So I hope you guys might want to try out FSQ sometime, and especially Friday nights between 8 and 9. Yeah, and see if you can hear us down in Hobart. Cool. Uh, Not really. Not. Yep, can hear you now. Yep. I have the standard license, so VK7LXX is standard 3-letter. I have recently failed my advanced test by one question. Yes, so I'm hoping that uh, the ACMA will actually change the rules and allow foundation licenses to do digital mode. No idea where I got the T-shirt from. Random Facebook advertisement. Standard does allow for automated operation. Uh, Another thing that we've been messing around with in Hobart is packet radio. So the good old AX25 built into the Linux kernel, and you can run TCP/IP on top of. So you could run a multiple telnet. Cool. Uh, the AX25 can actually relay through multiple hops. So you can do an AX call someone via someone else. Um, it's it's better if you use UDP. We set up a web server. It took about 4 minutes to download a GIF because of all the TCP ACK packets and retransmits. The balloon bounce. I think that's done with JT4, not Whisper, and I think they're now actually using a new mode that's similar. It's called QRA. Which is still very much in beta. But there's a lot of pico balloons that are in the air that are running Whisper. Cool. All right. Yeah. Well, thanks for letting me present, and hopefully we can do it again sometime soon.